Do you run Pi-hole on your local area network or home lab for ad blocking? Well, today we're going to look at Pi-hole with a little bit different perspective, and as I usually do, we're going to introduce some new terms and new ideas. Welcome back to the Scotti-BYTE channel, and this is Scott. I've entitled today's presentation High Availability Pi-hole and Local DNS. Pihole is most commonly considered to be an ad blocker, but it's also a local DNS resolver as well. And in February of 2023, I presented Nginx Proxy Manager and Local DNS, which is one of my videos with the highest viewership of all of my tutorials, and it's topped 20,000 views at this particular point. So in that tutorial, I installed a Pi-hole and I configured local DNS with an A record that was pointed to my domain name, and that A record was actually pointed to the address of my Nginx Proxy Manager. And I created CNAME records for all of my subdomains for local resolution of my services, which works even when my ISP connection is down. And if you're not running a local DNS and you're not doing local DNS resolution, you'll find this to be something that's really handy. So then we're also going to be considering mirrored Pi-holes, which is something I've done before, which basically means having more than one Pi-hole. So in May of 2023, I presented another tutorial entitled Mirrored Pi-holes to Provide Local DNS. And in that presentation, I showed how to use the GitHub project for Gravity Sync to replicate your primary Pi-hole to a backup Pi-hole, which uses the rsync service to replicate all of your local DNS entries. And in July of 2024, the Gravity Sync project has been officially retired. So we're going to replace Gravity Sync with another product on GitHub, which is called Nebula Sync. And Nebula Sync synchronizes multiple Pi-hole instances for data redundancy, and it performs a backup in the Pi-hole admin interface of your primary Pi-hole instance, and then it restores that backup to any number of secondary Pi-holes. We interrupt this program with Scott from the future, and I've discovered that Nebula Sync, although a great program to replicate our Pi-holes, is only available for Pi-hole version 6.0, which makes a significant change in the Pi-hole architecture. So although I will set up Nebula Sync initially because of the fact that that will be used shortly for Pi-hole version 5.x, which is current, we're going to use a different program to replicate called Orbital Sync. Anyway, back to your regularly scheduled program. So does Pi-hole actually fail over if you have a configuration like this? Well, Nebula Sync does keep your Pi-hole DNS servers in sync. But up until now, if you used your router DHCP configuration to specify your Pi-holes as primary and secondary DNS resolvers, and that's exactly what I've been doing. But I've found that DNS lookup failover when a Pi-hole goes down is not completely seamless, and I don't really think that's the fault of your router. I think perhaps that might be the fault of the DNS client in the various operating systems that we use. And so we're going to use Virtual Router Redundancy Protocol, or VRRP for short, to define one virtual address which would point to all of our Pi-holes. And we now provide the virtual address defined in VRRP as our primary DNS in your DHCP server configuration on your router. And VRRP will automatically point to the Pihole that's available if your primary Pihole goes down. So let's go see how to do this. Here we are at the terminal prompt, and in the top window I have my main Pihole instance, and in the bottom window I have my Pihole backup instance. I think one of the first things I'm going to do is do a Pihole-up in the top window, and that will go ahead and upgrade me to the latest version of Pihole. And likewise, I'll do a Pihole-up in the bottom window, upgrading the Pihole to the latest version there. So right now, Pihole is version 5.x, I think something like version 5.1.8 or something. But Pihole version 6.0 is coming soon, and when that comes, the existing copy of Gravity Sync will cease to operate properly, and that's one of the reasons to do this upgrade if you have Piholes that you want to sync with each other. And then also, if you don't have Piholes that sync with each other, we can show you how to set that up in this particular video. Now that both of my Piholes are updated to the latest version, I'm going to do a Pihole-V on the primary and a Pihole-V on the backup server. And you can see that they're both running version 5.18. My main Pihole and my backup Pihole are both running Gravity Sync, and so I'm going to want to uninstall that. If you're not running Gravity Sync, you don't have to worry about this step, but I'm going to do a Gravity Sync with the purge option, and it says this will remove your entire Gravity Sync installation. I'll do the same thing on the bottom screen, and I'll go ahead and type engage tractor beam like they said, and since I can't type real well, I'll just go ahead and make a copy of that, and I'll go ahead and paste that in the bottom screen, and I'll paste that in the top screen. I'll hit enter, and I'll hit enter on the bottom screen, and it says that it oh, I see. It needed a different command down here, fire photon torpedoes. Do you think maybe that the author may just possibly have been a Star Trek fan? So let's go ahead and put the correct phrase at the bottom, and it removed Gravity Sync on both my primary Pihole or my main Pihole and also my backup Pihole server. Over here on the web page for Gravity Sync, if we scroll down, it says effective July 26th of 2024, this project has been retired. And it says the last release version of Gravity Sync should continue to work with Pihole version 5.x, but not with Pihole version 6 due to architectural changes. And so that's another reason why I'm changing from Gravity Sync to Nebula Sync. If we go over to the Nebula Sync GitHub page and we scroll down, well, actually at the top here it says synchronize configuration of multiple Pihole version 6.x instances, and I believe it also is backwards compatible to 5.x, which we're running. And so here is the documentation for Nebula Sync. Nebula Sync is a Docker application, so rather than installing it inside of my Pihole containers, I went ahead and created a Nebula Sync container. And this is an Incus container. This could just as well be a physical machine like a Raspberry Pi, or it could also be a virtual machine. But since I usually discuss Incus containers on the channel, here I've launched an Incus container that is out on our main LAN. And now I'm going to go ahead and do an Incus shell into Nebula Sync. Okay, now from this point on, Everything else should be the same because it doesn't matter whether we have an Incus container or a VM or a physical machine. At this point, I'm going to do an apt update and an apt upgrade because assuming this is a new machine, I want to make sure that it is completely up to date. And it is. So at this point, I want to install a few dependencies that will be important in the process of all this. You may have these already installed on your machine, but I'm installing curl, nano, net-tools just because I like how it formats network information, and OpenSSH server so that I can SSH over to this machine later on. So I go ahead and do a Y for yes, and it installs all of those particular components. With my dependencies installed, the next thing I want to do is install Docker from the script on the Docker website. And I'm doing that because Nebula Sync is a Docker application. Now that Docker's installed, I want to go ahead and add myself a user account with an add user on Scott. I give the Scott account a password and I retype that password. Next thing I'm going to do is do a usermod -a capital G sudo Scott, putting Scott in the sudo group so that the Scott account has sudo privilege. And I'm going to do the same with the putting Scott into the Docker group. And the reason for that is so that Scott will not have to use sudo commands in order to execute Docker commands. Now I'm going to SU over to the Scott account, and from here we're going to go ahead and install the application. First, I'm going to do a make-dir on Nebula Sync because I like to put my applications in a folder by their name when I'm creating Docker applications, and I'm going to CD into Nebula Sync. Let's create a new Docker Compose file with nano compose.yml, and then I'm going to paste in the contents of that file, which will be in the show notes. So here I have a primary server, which is at 172.16.1.6 on my network, and then we have a pipe character, and then we're going to have the password for that particular server. And then we have a replicas, and I only have one replica, which is my backup server, and it's at 172.16.2.1. And again, we'll have the password for it. If we had any more servers that we had replicas for, in other words, if we had a tertiary server, we could simply start adding it with http:// and then we could put the address of it and so on down the line. But since I only have two servers here, I am only using two servers. And then we have full sync equals true. I don't know what a partial sync is, but full sync seems to be what we're supposed to be using. And then here I have a cron schedule on which this is supposed to run. And for right now, for demonstration purposes only, it's running each 1 minute. And you probably want to set yours up so that it runs maybe every 15 minutes or something else reasonable. We do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. Let's launch the application with a Docker Compose up-D, and it's usually a good practice to do an ampersand Docker Compose logs -F for follow the logs real time, and that way we can determine whether there are any errors. And so it's busy starting up right now. It says starting Nebula Sync version 0.2.5. And since I've heard pretty consistently that people like to see whenever I have errors, in this particular case, it does not authenticate. And the reason it does not is because it is trying to go down the path API/auth, and clearly Nebula Sync only supports Pi-hole version 6.0 and up. So based on that, we're going to go ahead and abort this with the Control C and do a Docker compose down. And we're going to use a different product to make this work. I'm going to go ahead and leave the Nebula Sync configuration intact since it's pretty close to the time when we're going to see Pi-hole version 6.0 up and running, so this will be handy later on. I'm going to do a CD back to the main folder, and just as a reminder, we have Nebula Sync here. So what we're going to do now is we're going to make another folder, and that folder will be for a product called Orbital Sync. So we're going to do a make dir on Orbital Sync, and then we're going to go ahead and CD inside of Orbital Sync. And then we'll do a nano on compose.yml, and we'll go ahead and paste in the Docker compose file for Orbital Sync, which will also be in the show notes. So this one's a little bit different in that we still put our primary host URL in there, which is going to be the address for the primary, then your primary host password, and then your secondary host 1, and it could be 2, 3, 4, 5, and so on if you had whole bunches of Piholes. But then we put the address in here the same way, and then the check interval, we're just going to set it up here as 1 minute so we can do a reasonable test. I'm going to do a Control O and enter to write the file out, and a Control X to exit the nano editor. And now that we have the Orbital Sync compose file in here, we'll just do another Docker compose up -d && Docker compose logs -f, and it will go ahead and pull that Docker container as well and start it. And once it starts, we should see the log file from it. And it does say that it is successfully signed into the primary server, and it is replicating to the backup server or uploading the backup to the backup server. So we know that this product is working. So I'll go ahead and do a Control C to exit out of the log. And at this point, if I do a Docker space PS, I should see that app up and running. If we wanted to get rid of the Nebula Sync container for now, but retain the configuration file, we could do a Docker system prune -a and go ahead and say yes, and it will go ahead and delete those containers that aren't up right now for Nebula Sync. But still, the Nebula Sync configuration file is in there so that we can use it later. And you'll notice this hasn't affected our running application, because if we do a Docker PS, there it is still up and running correctly. Here I am on the primary Pi-hole, and I'm going to click local DNS and then DNS records. And then up here, I'm going to go ahead and say AAAAA. And I'll say that the address of AAAAA is going to be 172.16.0.20. And then I'll go ahead and do an add. And you can see down here where we have 172.16.0.20. If we go over to the backup node and we look at local DNS and we look at DNS records, we're not yet seeing AAAAA because this thing is running on a schedule and it hasn't yet met that 1 minute. So we'll wait for just a second and then we'll look at it again. Now that a minute or so has passed, I go ahead and move myself back to the dashboard on the primary server, well actually on the backup server, because that's where the replication is supposed to be taking place. And then I go down to local DNS and click DNS records, and sure enough, AAAAA is back on the secondary. And likewise, if I go back to the primary and I go ahead and delete that AAAA record and we wait another minute, we'll find that it has disappeared from the backup server. After about a minute or so, we go back up to the dashboard and then we go back down here to local DNS and click on DNS records, and we notice that the AAAA node is now gone from the Pihole backup server as well. Now that we have replication working properly, we want to go back inside of our compose file, and we really want to change the interval minutes up to something more reasonable, because checking every minute is going to place unnecessary traffic out there on the server. So I believe that if my DNSs are updated or replicated every 15 minutes, that's going to be more than adequate. So I change this to 15. I do a Control O and Enter to write the file out, and a Control X to exit the editor. And then I can do a Docker compose up-d && Docker compose logs-f once again. And now it's going to go ahead and recreate that container and start it back up, and we'll see the log file, and everything should be working properly. The difference being is that it will only do a sync every 15 minutes. And so you can see it's doing its uploading, it's signed on correctly, and it says everything is successful. And when it gets done, it will say that it is waiting for another 15 minutes, and then it will repeat the sync at that point in time. Oh, there it goes. It says waiting for 15 minutes. So I do a Control C, which does not abort the Docker compose up-d. It only aborts the Docker compose log files. And to prove that, if we simply do a Docker PS, you'll see that the container is still up and running. At this point, my local DNS works, and I'm going to go ahead and exit out of the container over here, and I'm going to go back to VMS Mist. Actually, I'm going to go all the way back to my local machine, and in this case, I'm going to do an SSH over to Pihole, and that should log me in correctly, and it does. But I'm going to exit out of my Pihole, and now what I'm going to do is I'm going to go ahead and go back into VMS Mist, which is my Incus server, and I'm going to do an Incus stop on Pihole. And I don't remember what it's called, perhaps pi-hole. Okay, let's just say it's called pi-hole capitalized. And that's not it either. So if we'll do an Incus list, we should be able to find out what the name of my Pihole is, and it's actually Pihole main. So I'll do an Incus stop on Pihole main, and that stops that Pihole. Now, if I exit back out to my main machine and I try to do an SSH to VMS Mist, it sits there and waits forever because it can't do the DNS lookup. And part of the reason for that is because it's still pointing to that primary Pihole and not to the secondary Pihole as it should have automatically. Behind the scenes, I started my Pihole instance back up, and now I can do an SSH to VMS Mist, and once again it works. So the problem with this is we really don't want our DNS breaking just because our primary Pihole, which is doing our local DNS, goes down. The way around this particular problem is we are going to use something called Virtual Routing Redundancy Protocol, or VRRP. And VRRP uses the concept of a virtual IP address that we're going to define, which won't be the address of either of our Piholes, but it will be an address that is unused on our network. And one or more hosts are allowed to participate in the election of who is pointing to that particular main address to determine the host that will control the connection. And so only one host can be a master for that particular connection at a time, for the virtual address that is. And if that master fails, VRRP provides mechanisms for detecting that failure and quickly failing over to one of the standby hosts. In order to create this virtual routing capability, we're going to SSH to my primary Pihole. And over here on the primary Pihole, we're going to do a sudo apt install on a program called keepalive-d. And once that's installed, we're going to go ahead and configure it. To configure it, we're simply going to do a sudo nano on /etc/keepalive-d, and then the file is keepalive-d.conf. More than likely, that file is going to be empty. I'm going to go ahead and paste in the configuration file, which you'll see in the show notes as well. And this is saying it's a VRRP instance for Pihole. The second line is that this is going to be the master because it is the first system. And then we're going to specify the interface for that, which is going to be ETH0. Then we give it a virtual router ID, and this needs to be the same for all the systems participating in this particular VRRP. The priority of the master is always set at 255, and the additional nodes are set something lower than that. And then we have an advertise interval, and this says advertise the existence of this VRRP or check for its health every 1 minute. And then we have authentication, where the authentication type is a password. I've set the password here arbitrarily to be 12345, and the virtual address is simply an IP address on my network that I know is unused by anything else. I do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. I can then look at the service by doing a systemctl status keepalive-d, and for right now it says that the condition failed. I can go ahead and say restart the service, and now that there's a configuration file, it probably restarts, and if I do a status, it is in fact up and running because it has a valid configuration file. Now I'm going to go ahead and log off the main Pihole here, and I'm going to go ahead and do an, let's see, I'm not completely out there, exit out of that, and then I'm going to go ahead and go over to Pihole backup. So I SSH over to Pihole backup. Likewise, over here, I also want to do a sudo apt install on keepalive-d. And once keepalive-d is installed, likewise, I want to go ahead and edit the configuration file with a sudo nano /keepalive-d/keepalive-d.conf. And this time, we're going to paste in the configuration for a backup node. The main difference you notice here is that the state of this is backup. We can have as many backup nodes as we want, but only one master. Again, the virtual router ID is 7, but this time the priority is 254 because it's going to have a lower priority than the master. The advertising interval is still 1 minute, and then the authentication, we want to make the password match or else it won't be able to connect, and we give it the same virtual IP address of 172.16.0.10. So now I do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. Now that we've edited the configuration file, we can do a systemctl status keepalive-d, and I expect it also to be failed. Likewise over here, we have to go ahead and do a restart so it reads the new configuration file that we just created. And now if we do a sudo systemctl status keep alive d, it is up and running. At this point, our VRRP configuration should be up and running. I'm going to go ahead and exit out of my backup Pihole and exit completely back to my main system. To make all of this work, the next step is you have to head on over to your router. In my particular case, I have a Ubiquiti UDM Pro, and I'm editing my main network. If I scroll down in the list of configuration options, I want to go to DHCP Service Management and do a Show Options. When I scroll down here, I eventually get to DNS Server, which I previously had unchecked from auto because I don't want to get my ISP servers having used my Piholes. So here I had 172.16.1.6, which is the primary Pihole, and here I had 172.16.2.1, which was my secondary Pihole. What I want to do now is I want to change this to 172.16.0.10, which is now the virtual address that we're using for VRRP, and I'm going to clear out that second address down there. So I'm not worried about this configuration because if I were, I could go ahead and add myself a third Pihole for even more redundancy and also add it to VRRP. And then after searching the local Piholes for local DNS resolution, my upstream servers in Pihole are actually set to be the Cloudflare servers. So now I do an apply changes. We get this warning in the newer version of Ubiquiti Unified saying that you might want to disable DHCP conflict detection on all networks because it may slow down the ability to do DHCP leases. And I'm going to ignore this in this particular case because I'm satisfied with my configuration. And so now if I go back into that network and I scroll down once again and do show options just as a review, now the only DNS server that I have is 172.16.0.10, which is the VRRP address. To review my settings on my Pihole, as an example, I'm looking at my main Pihole, and if I click on settings down here and click on DNS, you're going to see that the upstream servers are set to Cloudflare. So let's see how all this works. In the top window of my terminal here, I have my local desktop machine, and I'm going to go ahead and do a ping on Piholes, and Piholes happens to be the address of my virtual VRRP address, which is, as you remember, 172.16.0.10. And so we're pinging that address continually. And then down here, I'm going to go ahead and do an incus list, and my primary Pihole, if we scroll up in the list, is Pihole main. So I'm going to go ahead and copy the name of that container, and I'm going to do an incus stop on Pihole main, which will shut that system down. And now that that system is shut down, we can watch the ping here, and we may see a brief interruption, and it will continue to pick up, and it is now pointing to the backup Pihole. And so we can also test that because in the bottom window, I can do a ping of something like my Jitsi server, or let's say my Rocket Chat server. And since my primary Pihole is down, you would not think that this would respond, but in virtue of the fact that we're using VRRP, we're still able to ping that system. And now, and this is sort of an interesting test to try out, we could always do an SSH over to Pihole. Now, SSH is not going to like the fact that the MAC address behind the scenes is changing, but we'll go ahead and do an SSH to Pihole, and it basically says no route to host, which is kind of interesting because what that means is it means that the primary Pihole is down, which of course we know. So now if we do a Pihole-backup, we're able to go over there and we can say, yes, we want to go ahead and connect to it. And there we are logged into Pihole backup. If I exit back out of here and I do a SSH over to Piholes, the Piholes address is the address of the VRRP, and that'll go ahead and connect to the one that's actually up, and you can see that that connected to Pihole backup. Now, as another test, we'll go ahead and exit out of this, and we'll do an incus start on Pihole main and give it a minute to start here. And now once that starts, I should be able to do an SSH to Piholes, and rather than connecting to Pihole backup, it should be connecting to Pihole main once again, since it's the master. You see the little interruption that we had here at the top, and then it came back, and that means that it is reconnected. So now we do an SSH to Piholes, and it says, hey, SSH doesn't like that address, so I'll go ahead and remove that because it doesn't like the MAC address changing for the target node. But now I'll do an SSH to Piholes, say yes, remember the fingerprint for that, and magically we are in Pihole main because VRRP has readjusted the address back to the master now that the master is available. So in summary, Nebula Sync replaces Gravity Sync to replicate our Pihole local DNS A records and CNAME records once Pihole version 6.0 is released. We used Orbital Sync to handle our replication while we are still running Pihole version 5.x in this video. And we used Virtual Router Redundancy Protocol, otherwise known as VRRP, to define a virtual address across all of our Piholes. And if your master Pihole is inaccessible, local DNS resolution will be automatically handled by the next available Pihole as defined by VRRP. And Virtual Router Redundancy Protocol is useful to provide high availability access to servers where you have replicated the required applications and data. And this example using multiple Piholes is only one thing that you could do with VRRP, but hopefully I got you thinking. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.